Today, we are going to discuss about data acquisition in machine learning, which is one of the most important foundational topic of machine learning systems. Before a machine learning model can learn anything, it needs a data, and the process of collecting that data is called data acquisition. In this lecture, we will understand how data is collected, processed, validated, and managed to ensure the high quality machine learning models. So, in the next slide, data acquisition refers to the process of collecting raw data from different sources such as sensors, databases, and application programming interfaces. This raw data is then converted into a structured format that machine learning algorithm can understand. The success of any machine learning model depends heavily on data quality, relevance, and diversity. Modern machine learning systems handle multiple types of data simultaneously, including structured data, unstructured data, semi-structured data, and metadata. And the data in like tables, unstructured data like text and images, and streaming data from IoT devices. The acquisition process includes data collection, data validation, data formatting, and data storage. If this process is not done properly, the machine learning model will produce inaccurate predictions. For example, customer behavior data from websites can be used for recommendation systems. Sensor data from machines can predict failures, and medical images can support AI-based diagnosis. The next one, the types of data sources in machine learning. The data sources in machine learning can be broadly classified into internal sources, external sources, and real-time sources. Internal sources include organizational databases such as customer relationship management systems, enterprise resource planning platforms, and operational logs. External sources include public datasets, APIs, web scraping, and social media platforms. Real-time sources generate continuous data streams such as IoT sensors, clickstream data, and financial feeds. In many real-world applications, we use hybrid data acquisition methods where multiple data sources are combined. Understanding the characteristic of each data source helps us balance data quality, data cost, data privacy, and data accessibility. For example, combining customer databases with social media data improves customer analytics, while IoT sensor data combined with the maintenance logs enables predictive maintenance. The next one, data acquisition methods and techniques. There are several methods used to acquire data in machine learning. Manual acquisition involves surveys, interviews, and expert annotations, which usually provide high quality labeled data. Automated acquisition uses scripts, scrollers, and APIs to collect large volumes of data efficiently. Sensor-based acquisition captures physical measurements such as temperature, pressure, or motion using hardware devices. Another popular method is crowdsourcing, where data labeling is distributed among many contributors. When real data is limited, synthetic data generation is used to create artificial datasets using simulations or generative models. Each method has trade-offs in terms of cost, speed, accuracy, and scalability. The next one is Data acquisition system architecture. A data acquisition system consists of several components working together. First, sensors convert physical quantities like temperature or pressure into electrical signals. These electrical signals are processed using signal conditioning, which removes noise and normalizes the data. Next, analog to digital converters. ADCs convert analog signals into digital values that computers can process. The processed data is then stored in databases or cloud storage systems for further analysis. Modern systems also use edge computing, where initial processing happens close to the data source to reduce latency. Examples include industrial monitoring systems, autonomous vehicles, and wearable healthcare devices. So, the next one, data quality and validation in acquisition. Data quality is crucial in machine learning because poor quality data leads to poor model development. Key data quality dimensions include data completeness, data accuracy, data consistency, and data relevance. Validation techniques such as schema checking, range verification, format standardization, and duplicate detections are used during acquisition. Real time monitoring systems detect missing values, anomaly detections, outlier identifications, and data drift. Automated validation pipelines ensures that only clean and reliable data ensures the machine learning pipeline. For example, sensor data can be validated for acceptable ranges, and dashboards can monitor acquisition quality metrics. The next one, challenges in data acquisition. Data acquisition faces several practical challenges. Volume of the data. Volume challenges occur when data sets become too large to store or process efficiently. Variety challenge or data variety challenges or arises due to different data formats and structures like structured data, unstructured data, semi-structured data, and metadata. Velocity challenges occur when high speed streaming data that must be processed in a real time. Other important challenges include data privacy and data security, especially when handling sensitive data under regulations like GDPR are the major aspect. Cost and bias are also major aspects of data quality, as data collection must be both economical and representative. Technologies such as distributed systems, standardized APIs, and stream processing platforms help addressing these challenges. And the next one is, what are the best practices for effective data acquisition? To achieve effective data acquisition, we must follow best practices while acquiring data. First, define clear data requirements aligned with machine learning objectives. Second, implement automated pipelines with proper monitoring and error handling. Third, establish storage data governance frameworks to ensure security and compliance. It is important to validate data at the point of acquisition to prevent poor quality data from propagation. Maintaining proper documentation of data sources, transformations, and versions ensures transparency and reproducibility. And the last one is emerging trends in data acquisition. Data acquisition is continuously evolving with new technologies. Edge computing. Edge computing allows data processing at the source, reducing latency and bandwidth usage. Federated learning enables model training without sharing raw data, which is especially useful in healthcare sector. AI-powered data discovery tools automatically identify and classify data sources. Other trends include synthetic data generation, blockchain based acquisition, and self service data platforms, which makes data collection more secure and accessible. These trends are shaping the future of scalable and privacy aware machine learning system. Therefore, in all aspects, data plays a crucial role, and this data also must be hygienic. The good quality data will facilitate to develop a good model. In fact, this data we have to collect from majorly four sources: structured data, unstructured data, semi-structured data, and metadata. Thank you.